Hello everyone, welcome to another Ansys Fluent tutorial video. Today we will go through an external aerodynamic and a compressible flow over the wing. So let's have a look on this tutorial overview. It's a transonic wing simulation in the Ansys Fluent. So it's we simulate the turbulent compressible flow over a 3D wing at a transonic Mach number. So what is this transonic Mach number? It refers to a flow regime where the airflow speed is close to the speed of sound, typically Mach number of 0.8 to Mach 1.2. And so this range includes both subsonic and supersonic flow regions within the same flow field. In this tutorial, the Mach number is 0.8395 and we have angle of attack 3.06, which you can see here. This is our Mach number and this is the angle of attack coming to this airfoil, and this is a section view of this airfoil at the bottom here. This is the ambient temperature, pressure, and temperature, and this is the dimensions of this wing. So flow actually, which is air in this tutorial, is going through this airfoil, and we are going to simulate the flow field around this transonic wind. As I said, we will use a K omega SST turbulence model, and then we will create a high quality capsule shape mesh using the watertight geometry workflow. And you will also see some aerodynamic boundary conditions suitable for high-speed compressible flows. And to solve this problem, we are using the pressure-based coupled solver with pseudo time stepping for state convergence. And finally, we will check the near wall mesh quality using the Y+ distribution plot. So let's get started. So first of all, it is good to see the geometry. We have a geometry created in the SpaceClaim, and if you need the geometry, you can ask for the geometry. So we can have a look on what we have. Here is actually the air around this airfoil at this center here. So we call this as the fluid in general, and we have some group here as our boundary condition. We have a symmetry at the bottom and this pressure far field here around the airfoil. So I can hide this one and also this symmetry. So we can move a little bit near to this geometry here, and this is our, just let me go to isometric view. Then we can see the section of this airfoil at the bottom. So I will go to this view and then zoom a little bit like this, rotate a little bit. So yes, here we have the wing surface at the bottom, wing at top, and we have one wing edge here using in the Ansys meshing. And also, if I go here to the structure, this is actually our fluid, but we have another part. We call it BOI, body of influence, that you will see here. That we will use this BOI in our Fluent meshing to have a better quality mesh after the wing. So here we will use a body of influence. So a body of influence is actually geometrical region, usually a solid body that you create around or near a part of your model, like this one. So this is after our wing, actually. So to influence the mesh resolution or refinement in the area without changing the actual geometry of the simulation domain. So the key purpose of this body of influence is to control mesh size or density in this localized region, uh, or as this is the important part, so it will use to refine the mesh in this important region. So as we now familiar with our geometry, let me go to the group again, select all, and then show all the boundaries, and then I can use the isometric view or geometric. So now we can switch to the Ansys Fluent and actually Fluent Meshing. So first of all, I need to select in the Fluent Launcher, I can select the meshing and then use double precision and this meshing process for processors, and then choose my working directory here. If I scroll here, so you can choose your working directory. My SpaceClaim file is located here, so I can just press start and then wait to open the Ansys Fluent Meshing. So after a short pause, the Fluent Meshing is ready to use. So you have two tabs here, workflow and outline view. So we are working in the workflow now, and then we need to use watertight geometry. So there are a few steps and tasks actually that we need to do and finalize and go step by step to finalize our mesh. So first of all, we need to import our geometry. So keep the file format as CAD, because it is coming from SpaceClaim, and the unit to millimeter. Then select your file name to import your geometry. Okay, so now I can select my geometry wing with this format, SpaceClaim. So I will press on the OK, wait to import my geometry. So the first task is done. Now we need to add some local size, which is very important in this case, in this compressible flow over the wing. So in this tutorial, I will add the local sizing around the wing and the region past the trailing edge, since they are areas where we require a more refined mesh. Later, we will apply setting for a coarser surface mesh elsewhere. So let's get started. First of all, to answer this question, I will select yes. So now we can add some local sizing in this case. So first of all, so let me hide this too. Okay. As you see here, we have two surface wing bottom at the bottom of the actually here, let me go to the bottom view. You can see more better like this. So this is a wing at the bottom, and this surface is wing top. So in this case, I'm going to add some local sizing on these two wings. So I will go here, call this one as wing face size. Okay, so now I'm going to just hide this surface. So you can use, and we can use this toolbars here. First of all, I will select the zoom selection filter here, and you will see this text. It's like a help text here. Zoom selection filter. You can activate or deactivate this help text here in the display menu. And if I uncheck, so you can see, you cannot see actually the text or explanation of each toolbars. For example, here, but if I activate, so you can simply see the explanation. So I will select the zoom selection filter, select this far field area, and then I can use another toolbar here, hide. So this area will be hide. I can zoom a little bit on this one and bring this console down, make it a little bit bigger, and I will, and now again go to this local sizing for this two surface wing at wing button and wing on top. I will keep this face size as it is a face, and then I will change this target mesh size to 10. And when I select these two surface just by clicking on these two, so you will see one preview of your mesh size around the wing actually here, and this is your first local sizing. You can see, for example, if I make it bigger 4D, so it will increase, but in this case we need better mesh, so I will select 10. So, and after that I can add the first local sizing here in this area. Now you can see the wing task actually in the workflow, which can be selected, change. So this part is also, this local sizing has been done, but this is only one local sizing. We need more local sizing for this problem. So this task can still be used to add more local sizing, control the geometry. So now I will add another local sizing for the edge that we have created and explained before. So I rename it to, I'm going to add one more add local sizing beside the first one. So I will call it wing edge face size, which is this one. But we can see again, I will keep this face size, but this time as we need more smaller meshes, I will just check specify 2 for this target mesh size, and then in the this selection part I will select wing edge. You will see here the green the yellow line edge here, so I will select this one here. So we have another local sizing. If you want to check this, I will increase the size to see. So this is related to this edge actually, so I will keep 2 for this target mesh size. For the second, it's here for the actually second local sizing, so I can just add another local sizing by press on the add local sizing. So now we have 2 local size, first for 2 sides of the wings, and one is for this edge actually. So we are going to add another local sizing, but this time for this body of influence. As I explained before, the purpose of this body influence, so we will have some fine mesh here in this body influence section. So for the third time I will add one name, wing BOI, body of influence. But this time, this size control type, I can select body of influence. So Fluent knows that this is for body of influence, and then I can enter and specify 5 for this one. So now in this region, so Fluent knows it should be go to the region that we have. I will select wing BOI, so it knows that this local sizing for this face and area body of influence, and we will see the preview of the mesh size here. So I will add another and last local sizing. So now I have 1, 2, 3 actually local sizing here. So next step and next task actually is to generate our surface mesh here. So I just zoom out a little bit. So you will see some other meshes here. So we need to change some of these settings here to have a better resolution of mesh. So here I will just change this minimum size to 2 and the maximum size to 1000. So the maximum size is almost the same as the default, but I decrease the minimum size to 2. So now I have a fine minimum size and good maximum size for this region, and now I can generate the surface mesh. Okay, so this surface mesh is also has been done, and you will see this part also checked as a green check mark, and we need to go to describe the geometry now. I just go to the isometric view. But before going to this describe geometry, we can just have a look on our surface mesh. So this is for the far field area. So we have a rather good mesh here, but we can go and check the wing also as we add these 3 local sizing. So again, I will select this filter, zone filter, selection filter, click on this far field area, and then hide this zone. I can zoom into the wing. So we actually have a good mesh for this problem. And also we have a fine mesh after this wing. This part is related to our body of influence, so you will see a fine surface mesh here, and then the size of mesh will increase alongside this domain. So now I can show again all the surface, go to isometric view, and then click on the describe geometry. So we need to fill out and select our geometry. So in this case, this geometry consists of only fluid region with no voids. So I need to select the second option and then keep the rest of the default setting task, and finally click on describe geometry. So this part is also has been done. Base our group name in the SpaceClaim. So the boundary conditions specified in this Fluent Meshing software. So we need to update our boundary condition. We can check this wing button, wing edge, and wing top are wall type, and so those are correct. And pressure far field is a pressure far field type, and the fluid symmetry boundary type is symmetry. So all are correct, and so we can update the boundaries also. And so this task is also done here. Very good. Next task is the update the region, and we have only one region, which is a fluid region. So this region type is also correct, and we can update the regions. So this part also has been done, and now it's time to add some boundary layers to this geometry. Okay, so for this boundary layers, just ensure that this add boundary layer is select to yes, and then keep other parameters as the default. Only change the number of layers from 3 to 12 boundary layers actually. So in this case, many boundary layers are desired to model a well resolved flow near the walls. So we increase this number of layers to 12, and then finally add these boundary layers by clicking here. So this part is also has been done, and finally we need to go to generate our volume mesh, final step in Fluent Meshing. In this case, as I explained in the first slide of this presentation and this video actually, I will use the polyhex core for this geometry, and so I will select this one here. Then I will decrease this maximum cell length to 512 and keep these two options as the default. Only I will go to this advanced options, and then change this check self proximity from no to yes. You can see the explanation of this parameter here. So for example, you will actually choose whether or not by yes or no would you like to check the proximity issues such as the overlapping surfaces, very small gaps between surfaces, very sharp angles. So problematic areas will be highlighted in the graphic window if this option is set to yes. So that's a very useful options in the generating the volume mesh. You can set as yes, and then finally generate the volume mesh. So I just pause the video and then come back again after generating the mesh, volume mesh. Okay, so this volume mesh generation has been done, and then so Ansys Fluent applied our setting and proceed to generate a volume mesh for our geometry, and the mesh as you see is displayed in the graphic window and the clipping plane. You will see here is automatically inserted with a layer of cells down so that you can quickly see the details of your volume mesh. You can also change this one, and this clipping is always in the X direction in the Fluent Meshing, as you see. So you can check your volume mesh here. You can also check in another direction, for example, like this one. And this is our volume mesh here. Very nice and good polyhex core mesh in this tutorial. So just I will go to the mesh to check the mesh here, and you will see some reports in the console here. So I can check the minimum volume, for example, here, which is not a minus value, so that's good, and there's no issue here. And then finally I can save the mesh from here, file write mesh, then I will choose the same name. So the generated volume mesh has been saved. And okay, so now the mesh is ready to use in the Ansys Fluent with the switch to the solution. So we can go and switch to the solution and just here, but yes, pressing yes. So we will switch to the Ansys Fluent mode, and then in the next video you can see the setup in Ansys Fluent and then post-processing of this geometry. So you can just wait a few seconds, and then now we are in the Ansys Fluent mode to set up our geometry. So that's it for this video. Please go and watch the next video of Ansys Fluent part of this tutorial. Thanks for watching.